Well, thanks everyone for joining us today. I'm Alex. I'm a networking specialist solutions architect with AWS. And I'm joined by Pratik Mankad. He's also a networking specialist solutions architect, and by Chauvin Das, a product manager on the EC2 networking team. We are going to be talking today about how you can use AWS products to build global secure connectivity, right? Before we jump right in and we get started, let's go through a couple of housekeeping items. First, this is a 300 level session, so it's not expert, it's not entry level. We will be covering 3 services today: AWS Cloud WAN, Amazon VPC Lattice, and AWS Verified Access. We'll let you know when a build out is complete. We love animations, so you'll see a lot of animations in the slides. We'll let you know with that icon when the build out is complete so that you can take photos if you wish to. The session is also going to be recorded. And we will have QR codes that will pop on screen for you folks if you want to scan them and read more detailed information on the things we're talking about. Now that we've cleared the housekeeping items, let's see what you folks are going to be looking at the session today. First, we will start by building a global network that is segmented as well with AWS Cloud WAN. We're going to see that building a secure global network and security strategy starts with the layered approach, right? So we're starting with Cloud WAN. Second, we will see how you can integrate zero trust principles into your service-to-service communication, right, with Amazon VPC Lattice, and how VPC Lattice integrates actually with your deployment on Cloud WAN. And third, we are going to be looking at how you can bring in AWS Verified Access to secure your end user communication with your services on AWS. So this is our agenda for today. But before we dive right in, first and foremost, let's clarify one very common construct that keeps appearing in conversations with all of you at Inforce here and in our day-to-day business and operations. This is the concept of zero trust. And zero trust has a lot of definitions, right, for a lot of people around there. But conceptually, in AWS's view, right, zero trust is a security model and an associated set of mechanisms that focus on providing security controls around your digital assets that do not solely or fundamentally depend on traditional network controls or network perimeters. Very important there. So how do we bring in, essentially, identity and networking capabilities together? We're not taking networking security and putting it aside. We are integrating it with identity features and capabilities to bring these two worlds together, right? Now, to build this layered security approach and to integrate the two worlds, we have to start with the foundations and fundamentals of security on AWS. And here is where we start by looking at the AWS account, right? The AWS account is your security boundary on AWS around your assets, right? You start creating multiple accounts, you have that security separation in terms of IAM roles and access controls and all the security functionality around those assets. The second boundary we need to talk about is the Amazon VPC, Virtual Private Cloud, which is your network boundary in AWS, right? So we take these two and we work together with them as a foundation, right? Now, if you look closer inside the VPC, I know probably all of you are familiar with network access control lists, right? We have 2 types of subnets that you can deploy in your Amazon VPCs: public subnets and private subnets, and network access control lists live around each of these subnets, right? And they control access at the subnet level between different resources that are outside of the subnet and the resources inside the subnet. Network access control lists are stateless, right? And they're your network level subnet controls for access. The second security control that you have inside the VPC is the resource level security through security groups, right? These security groups are your resource-bound firewalls. They are stateful, and you can control access to your resources using security groups. But as we grow and as we scale the footprint on AWS, right, we start having multiple regions, right? We start deploying multiple VPCs across these regions. We increase our footprint, and we start having multiple roles associated with those VPCs, right, and those different accounts that we're creating. We have here identified, for example, production VPCs, development VPCs, staging VPCs, all the types of workloads that you can deploy on AWS, right? And going even beyond that, beyond the footprint of what means your workloads on AWS, we have data centers that we need to connect to, right? And we have office locations and remote users. And the idea here is, how do we bring all of these network-related footprint areas, right? How do we connect them all together, and how do we maintain that same security standard across all of them? So, first and foremost, we are going to be starting by building this global network connectivity with AWS Cloud WAN, and Pratik is going to take us through this journey. Pratik?
Thanks, Alex. So, what is AWS Cloud WAN? AWS Cloud WAN is a managed wide area network service which allows you to create a unified global network that connects resources running across your cloud and on-premises infrastructure. It provides a centralized dashboard which you can use to connect your on-premises branch offices, on-premises data centers, Amazon Virtual Private Cloud over AWS Global Network. It also provides a simple network policy that you can use to centrally configure and manage and automate network management and security tasks, and get a unified view of your global network, a single point of view for your global network. So with that brief summary, let's take a look at a few of the key components of AWS Cloud WAN. So first thing that you need to do is you need to define a global network. Global network is a single private network that acts as your high-level container for all your network objects. Once you have defined the global network, you go ahead and you create a core network. Core network is a part of your global network that is managed by AWS, and it's basically, it enables the regional connectivity as defined in your core network policy document. So the next thing is core network policy document. Core network policy document is a single document that allows you to apply your intent, your network intent to the entire, to your core network. It's a declarative language, a JSON-based policy document that allows you to define network configuration, network segments, segment actions, attachment policies, and such. The next thing is core network edge. Those are the regional connection endpoints that are again managed by AWS network. And so again, based on the regions defined in your core network policies, AWS Cloud WAN creates the core network edge in those regions. And this core network edges form a full mesh peering and creating a basically highly resilient network. And all your attachments connects to this core network edges. So the next one on the list is segments, network segments. These are nothing but your route domain. So if you compare it with your traditional network, this is similar to virtual routing and forwarding. And the last one, but not the least on the list, is attachments. So any connections or resources that you want to connect to your AWS core network. And today we support VPC attachments, VPN attachments, transit gateway route table attachments, and transit gateway connect attachments. So with all those components in place, let's see how they kind of come together, how they work together. So you first create a core network. So again, you define in your core network policy where you want to enable your regional connectivity. It goes ahead and creates those core network edges. Core network edges under the hood are similar to transit gateway, so they inherit a lot of similar properties. You create the core network. Once you have created the core network, you go ahead and start populating, you start defining the core network policies where you create your segments. Network segments can be a production segment, can be a development segment, can be a test segment and such. And you then go ahead and define attachment policies. So there's a section within core network policy document where you go ahead and create attachment policies, and using the tags on the core network attachments, you map attachments with the respective segments. So basically we automate the whole mapping of an attachment with the core network segments. And then on the other side, you have on-premises infrastructure such as branch offices and data centers. So you go ahead and again, you can create a centralized global hybrid connectivity using AWS Cloud WAN. So you can use direct connect, connecting to core network through transit gateway. We will take a look at that in a minute. Or you can use VPN, like your branch offices connecting to your AWS through VPN. So you can, basically with that in place, let's take a look at how you can build global network connectivity and segmentation with AWS Cloud WAN. So we have two regions here, US East 1 and US West 2. You create a core network that spans across this two regions. So core network basically ends up creating core network edges, full mesh, we manage it for you. And once you have created the core network, you go ahead and create a network segment. In this example, we create a production network segment. You go ahead and map your production VPCs, you create attachments and map it to the production segment using attachment policies and tagging on the respective attachments. And then basically what you need to do at this point is you need to go modify the VPC route table and point the traffic towards the core network. So we added a route in this, it supports both IPv6 and IPv4. You add a route pointing to core network, so prod VPC can now communicate with, in East 1 can communicate with prod VPC in West 2. So moving on, you can add more segments. You can create a development segment where you can map your development resources. Development VPCs can be mapped to development segments. You can then create a shared service segment. So you might have a shared service that you want to share it across all your production and development segment. So by default, all the segments are isolated. So what I mean by that is attachments mapped to the same segments can communicate with each other. Meaning you cannot, a prod VPC by default cannot talk to a dev VPC mapped to the development segment, and vice versa. So if you have a scenario where you want to have a shared service and you want resources from those segments to talk to each other, you go ahead and basically create what we call a segment sharing. Again, you define this, configure it in your core network policy document. So here what we do is we share the shared service segment with the production segment and the development segment. And what it does is basically it advertises the routes between the two segments. So let's take a look at the route tables with that, right? So in the production network segments, you have prod VPC siders, and because it is shared with the shared service segment, you also see the routes from the shared VPC segments. Similarly, in the dev segments, you have routes from the dev VPC segments as well as the routes from the, because again, it is shared with the shared service segment, you have routes from the shared segment, so you see those routes. And then in the shared service segment, you see basically because it's shared with the prod and the dev segment, it has routes from respective segments. So this basically enables the connectivity, like prod can talk to resources in shared services, dev can talk to resources in shared services. So with that in place, right, so the next thing that comes in mind is like, okay, I have created the network connectivity and segmentation, but I still want I isolated the prod and development segment, but there's a use case where I want to, allow prod and dev communication, but I don't want them to communicate with each other without going through a security construct like a firewall. So how do you do that, right? So let's take a look at integrating security constructs into your network path to inspect and protect your network traffic. So building on the example that we had, we go ahead and create another segment called inspection or a security segment. We go ahead and create inspection VPC in each regions where you have your security constructs like AWS network firewalls, or you might have a third-party firewall sitting behind a gateway load balancer running for your traffic inspection. You go ahead and create those attachments and map it to the shared inspection segment here that's shown in the diagram. And at this point, what happens is the security segment is shared with the development segment and the prod segment. So let's take a look at the packet flow. So we have a resource in a dev VPC that wants to talk to a resource in a production VPC. You have a route pointing to the core network. It lands on the core network. It does a route table because it's mapped with the dev network segment. It does a route table lookup. It finds a route pointing to the inspection VPC. Packet gets routed to the inspection VPC where packet gets inspected by a firewall. Depending on the policy configured, the traffic is allowed, comes back, VPC route table points it back to the core network. And at this point, because inspection VPC is mapped with the security segment, it does a security segment route table lookup. It finds a route matching to the destination, which is your production VPC. So this is how the packet flow packet gets routed from dev VPC to the production VPC through your security devices. And basically, we inserted your security appliances in the network part to protect your traffic. So you can, they're like, we have created reference architectures for security inspection, so you can scan the QR code. We also have a Chalk Talk NIS301 happening later today and tomorrow on the same topic, so feel free to attend that as well. So the next in line is centralized, how to use AWS Cloud WAN to connect your on-premises infrastructure and create, centralized global hybrid connectivity. So again, building on our example, so we have this going on. So we create yet another segment called hybrid segment. And we go ahead and you have 2 data centers located in 2 different regions. And they connect to the AWS through Direct Connect Gateway. And Direct Connect Gateway connects to the AWS Cloud WAN core network through Transit Gateway peering connection. So this Transit Gateway peering connection allows your AWS core network to connect to your Transit Gateway in the same region. And you can create 1 or more Transit Gateway route table attachments and selectively exchange routes from a specific route, like Transit Gateway route table, to a specific core network segment, and in turn achieve what you call as end-to-end segmentation and network isolation. So we did that using Direct Connect. If you have branch offices connecting to your AWS, you can use site-to-site VPN and basically do the same thing. You can map it to the hybrid segment, and here we have achieved the goal of creating a hybrid network using AWS Cloud WAN, where your on-premises infrastructure can communicate with resources on your AWS cloud. And what we have not shown in this diagram is let's say you have a policy where you want to inspect the traffic between your on-premises infrastructure and your resources on the cloud. You can, again, using route table, core network route tables, you can route the traffic to the inspection VPC, get inspected, and then send it out to the resources on the VPC. So this was all with, we created global network connectivity and segmentation with AWS Cloud WAN. We created a centralized global hybrid connectivity, and then we also saw how you can insert your security constructs like firewall and third-party firewall inside into the network part to inspect and protect your network traffic. So let's bring it together. Let's bring together the network and identity on AWS with Amazon VPC Lattice. Thanks, Alex.
Awesome, thank you. Cool. So we've built the network, right? We have our global network, we have our global segments, we have hybrid connectivity brought in through Cloud WAN. We have our inspection between different segments on Cloud WAN. Now, how do we secure and how do we bring this level of zero trust between service-to-service communication, right, on AWS? And here's where Amazon VPC Lattice comes into play. First, before we jump in to see how we integrate VPC Lattice with our environment, we take a step back and we look at a bit of the paradigm between network people, admins, right, which probably most of you here are, and service owners or application owners, right? And there's always this number of issues that these 2 personas need to come together to solve, right? There's the overlapping IP addresses. I'm probably hearing this every single day in conversations with customers. I'm There's the developers or application owners who are asking, how can we simplify our deployments? How can we have, for example, the flexibility of deploying on EKS platforms or Kubernetes platforms? How can we use EC2 as well? How can we use also Lambda functions? How can we achieve those advanced traffic routing controls? How can we do blue-green deployments? How can we do canary-style deployments? How do we get visibility? How do we reconcile the fact that account level boundaries and VPC level boundaries are different, right? So all these words here on this word cloud sort of highlight or outline the need for these two personas to come together. And here's where Amazon VPC Lattice comes in, right? To bridge the gap between these two personas and between what the admin team built, right, with Cloud WAN so far, and the application needs. So Amazon VPC Lattice is an application layer service that provides application layer functionality together with network connectivity, right? And allows you to integrate those zero trust, strong authentication principles, authentication and authorization through the use of IAM auth policies. It does allow you to connect your services across various compute platforms. So you can have Kubernetes, you can have Lambda functions, you can have EC2, you can have ECS. They are all integrated with Amazon VPC Lattice. It allows you to create those rich traffic level controls, right? Which is the admin side of the house that it's not very common, right? Whenever service owners come in and say, what are my requirements here at the network level to make this work? It's usually, well, load balancers, AOBs, NLBs, and so on. And last, it streamlines service-to-service interactions, right? A lot of the times when we're talking to customers and they have these services connected to the segments that we've seen earlier in Cloud WAN, they do want to have the added layer of controls of which service can actually talk to which other service, not having everything just be able to talk to everything else within that, for example, Cloud WAN segment of production. So starting from here and simplifying application networking, let's look at the Amazon VPC Lattice components, same as we've done with Cloud WAN. First, we have the service network, which is a new logical boundary that helps simplify bringing together connectivity and applications, right? So the service network boundary will define how that connectivity and how service-to-service communication will work. Second, we have the service. It is a VPC Lattice service, this construct, and represents an application unit that you can identify that can span across different types of compute options, across multiple accounts, and across multiple VPCs. So you're no longer bound to your boundaries of VPC level and account level. Third, we have the service directory, which is the totality of services that you've defined within your account and that have been shared with your account using Resource Access Manager, right? So that you have access to them to associate them with service networks. And we're going to dive deeper into that in a second. And last but not least, we have security policies, which are IAM policies, authentication, and authorization. And they can be applied in two places. We're going to see that in a second, at the service network level and at the service level. And they come together to offer different levels of control for the network folks, the admins, right, and the service owners. Now, let's see how all these come together and how Amazon VPC Lattice works. First, from the admin persona perspective, we have the infrastructure account most often. In the infrastructure account, we create the service network. Once the service network is created, it can be shared with other accounts within the organization or outside the organization using AWS Resource Access Manager. Once the service network has been shared, VPCs can be associated with it, right? Once these VPCs are associated with it, with the service network, they're able to access services within the service network based on those auth policies that have been configured. So the job of the admin is this, right? Last, from the security perspective, and here we're talking not just about the network folks, but also the security admin persona, there will be a set of policies that can be enforced at the service network level for access control within the service network. And here, one of the most common ones that we are seeing is, for example, setting that traffic through the service network has to be authenticated, right? That's the one of the primary policies that you can set. And it's already a very strong one. So traffic through the service network cannot go if it's not authenticated, which is very important from security stance perspective. Then if you want to go more granular, you can go more granular with the policies at the service network level or at the service level. And last but not least, which is probably one of the biggest pain points between these two personas, is the monitoring and visibility. And you have two layers of monitoring that show you, for these two personas, the same set of information. Monitoring enabled at the service network level gives you access logs, right? And the same access logs are exposed to both the admin persona and the service owner persona. So this is where these two personas now come together, and they all, for troubleshooting purposes, look actually at the same thing, right? They all see the requests, they all see the IP addresses, they all see the headers, and all the information exposed to those access logs. Now, from the service owner perspective, right? The service owner owns services, right? Owns applications. And their first task is to essentially define services in VPC Lattice. These services can be, again, multiple target groups across multiple VPCs, across multiple accounts. And once these services are defined, within these services, you define routing policies, right? Routing policies that can be header-based routing. You can define path-based routing. You can say, I want blue-green type deployments and canary deployments and so on. The third task for the service owner, in collaboration with the admin on the security side, right, is to define service level auth policies. And here's where the service owners can granularly control what other services within the environment can access their services within VPC Lattice. And last but not least is associating services with the service network. A service can be associated with multiple service networks. We're going to dive deep into the architecture in a minute. But the idea is that when you associate a service with the service network, that service, based on the auth policies, right, both at the service level and at the service network level, is or provides clients within VPCs the ability to access it, right? So it becomes available within that service network. Now, we've seen what the two personas are doing, right? If you folks want to know more about VPC Lattice and how step-by-step deployment looks like, scan the QR code. Let's dive right in, right? Let's see how we can integrate it with our environment, right? That Pratik helped us build. So we're starting from our Cloud WAN deployment, right? We have this global core network, we have our segments, we have hybrid connectivity and all things. Now, one of the most common use cases that we're seeing, and a very, very good starting point for integrating VPC Lattice in your environment, is a common scenario where we have production and shared services. We have multiple segments, but let's say production and shared services. All these VPCs live across multiple accounts, and for some reason, right, one reason or another, right, we have VPCs, either due to acquisitions or IP management or choices that were made, that has overlapping IPv4 space. And the question here is, how do I get services to talk to each other in this paradigm? Getting it attached to Cloud WAN and performing private NAT could be an option, right? The other one is using VPC Lattice. Across these three VPCs, we have a lot of services that have been deployed, right? We've taken some examples to show the functionality across multiple compute platforms. And our question for now is, how do we get them to talk to each other? Well, again, our admin comes in first, and you see that the connectivity with Cloud WAN isn't going anywhere. It's still there. It just went into the background for a bit until we see how all VPC Lattice constructs are integrated. So first, it's creating the service network, right? We've called this service network prod. You don't necessarily have to have a prod service network and a dev service network and a shared services service network and so on. You choose how you architect this. You have the flexibility provided to you by the fact that a VPC can be associated with a service network and services can be associated with multiple service networks. This is just an example. So we've created the service network. Now, the second step is to associate VPCs to the service network. We are associating the VPCs that will need to access services, right? So in these VPCs, we can assume those services that we've seen on the previous slide are also clients, right? Our third step is to configure auth policies. We can start from the most basic one, which is allow only authenticated traffic, right? Now, because we've said that these two personas come together, right? We've brought in the service owner. And the service owner takes the applications and registers them into VPC Lattice as services, right? So you can have services based on auto-scaling groups in EC2. You can have services based on EKS and the gateway API integration. You can have services just as IP address targets. Now, we're defining the services and we're defining the routing policies, whatever those routing policies at the application level may be. The second step is to configure service level auth policies. And here we can say, for example, that service A can talk to service B, but service C cannot talk to service D, right? And the third step is to actually associate those services with the service network to make them available to be accessed within the service network, right? So these two personas came together. They did all these steps so far, right? Two things to consider, very important. VPCs that have clients that need to access services within the service network need to be associated with the service network. And the second, services that are associated with the service network can be accessed, right, based on those policies. So you have the flexibility here to integrate VPC Lattice constructs, right, depending on your access patterns. You don't have to do it for everything, right, all of a sudden. Now, if you folks, I mentioned the Kubernetes Gateway API integration. If you folks want to read more about it, VPC Lattice is natively integrated with Amazon EKS. Very good read. Now, let's look at the life of a packet, because I feel that there's a lot of folks here who are like, okay, this looks good, but how does this actually work, right, under the hood? So let's take, for example, our two VPCs, right? VPC1 prod, which is the one that's actually attached to Cloud WAN, and VPC2 prod that has the overlapping IP space. Now, service A and service E, they're both associated with the service network, and both VPCs are also associated with the service network in our example. Now, first, whenever a service is created in VPC Lattice, that service gets an FQDN. That FQDN is managed by VPC Lattice in public hosted zones. You can choose to configure and use custom domain names with DNS, right? We're not going to dive deeper into that setting specifically today, but you have the ability of doing that. So let's say that our two services get some hash-generated VPC Lattice maintained DNS names. Both in IPv4 and in IPv6, right? So they get A records for both. Now, DNS. I mentioned the keyword. That is going to be our service discovery. But before we get there, when a VPC gets associated with the service network, there is a security group on that association. Very important. And here's where we started our presentation, right? We reviewed the security controls that you have at the VPC level. The reason for that is because you might not want to give access to the service network to everything that lives within that VPC. You might want to say, okay, I want granular control over what in my VPC can access services, can access the service network to begin with, and what cannot. Now, if we dive deeper into what our actual service is, right? Our example, in our example, it's an auto-scaling group with just 2 EC2 instances across 2 subnets, right? Now, those security controls that we've seen at the beginning at the VPC level still apply. So each subnet has its own network access control list. Each subnet has its route table. And when the VPC is associated with the service network, the route tables get automatically populated with the VPC Lattice managed CIDR blocks, right? So IP addresses used by VPC Lattice. That is what you see there. And you also have the security groups at the resource level, right? We have EC2 instances, we have the security groups that are there, and you associate them with your resources. Now, all these will play a very important role because they are in the data path, right? They are making their security contributions to your layered security approach. I mentioned DNS, and here is what DNS helps services do. It is the VPC Lattice service discovery mechanism. And it is essentially the one that dictates where the traffic should be going to, right? If, for example, my service says, well, I need to talk to service E, right? Service E could, again, have that custom DNS name. And you could also have a C name in your private hosted zone that actually does that, your custom DNS name to the VPC Lattice DNS name association. So let's say that our workload here, service A, does a DNS query and says, okay, well, how do I get to service E? The way in which you get to service E is essentially determined by the DNS response. If the DNS response is a 169.254 address or an FD in IPv6 address, then the traffic will flow according to security groups, route tables, to VPC Lattice. If your DNS response is going to be 10.1.1.20, right, somewhere within your network, that traffic will go to Cloud WAN, because that's what the route table says. So let's take a closer look. First, we have an IP packet, right? That's where we get to. The IP source is the actual IP address of the resource. The IP destination is what we got in the DNS query response, 169.254 or an IPv6 address. Now, this packet needs to be first allowed by the security group at the resource level. Then, it needs to be allowed by the NACO. It needs to go based on the routing rules in the routing table, right, to VPC Lattice. And it also needs to be allowed by the security group at the association level. And now, the packet got to Lattice. Here in the service network, there are the auth policies that you configured that get applied both at the service network and at the service level. All the traffic routing controls that you've applied, target groups, everything that needs to be there, part of the configuration. And traffic is routed to the destination. That destination service is service E, which again is a set of resources that lives in a subnet with security groups and NACLs and all the things that need to allow that traffic. So you have the defense in depth approach, right? You're not compromising on your security controls, you're using them additively to the network level controls. Now, our traffic flow looked good between the two VPCs with overlapping IP space. I think we even forgot that. We solved the problem of overlapping IP space, right? Now, another problem with these two VPCs that have overlapping IP space is how do they get to access shared services? You mentioned private NAT, that's an option as well. Well, let's look at the traffic flow, right? We have the two VPCs. They're both associated with the service network. Service A and Service E are associated as well. And we have our shared services VPC. This is a very common use case with services that need to be accessed by everyone within the organization. Be it, I don't know, artifact storage services, authentication storage, types of services, and so on. So these shared services, we've taken an example here. It's shared service A. It is also associated with the service network. You see that the VPC is not attached to the service network. The reason for that is because in our example, service X doesn't need to access anything within the service network. It just needs to be accessed, right? So just the service is associated with the service network. If it would need subsequently, right, to get access to other services associated with the service network, the step to do there would be just to associate the VPC as well, right? How does the traffic flow look? Well, same as the life of a packet that we've just seen, right? Assuming that security groups and NACLs and route tables are configured accordingly, the traffic flows from the two VPCs to the shared services and back. There's no need to perform private NAT here, right? There's no need to add additional components into the architecture. Now, probably there's a question that lingers, which is, okay, cool, so we have done all this with Cloud WAN, right? We have our global segments, and we have prod, and we have dev, and we've seen how to solve this use case for production VPCs access to shared services. But how do we look back, now this integration is done, at the types of traffic that need that level of inspection that Pratik was mentioning, right? We don't want to let prod and dev talk to each other, or on premises talking to prod, or whatever other inspection mechanism or policy you have, to talk directly, right? We still want that inspection to happen. Let's see how it works. In our more advanced example here, we have a production service network that deals with production service-to-service communication. We have an example for the dev service network with our dev service that is associated and registered there. We do still have, as part of our Cloud WAN deployment, right, in our security policy deployment, our inspection VPCs, which are associated with the inspection segments. So whenever traffic needs to go between these different levels of security controls, right, between these different segments that have different security postures altogether, and you need this traffic to be inspected. Again, we're coming back to DNS and how DNS gets resolved, and the route tables of VPCs, and the fact that that traffic is still able to go through Cloud WAN, right? It doesn't impact that traffic flow at all, the fact that the VPC is associated with VPC Lattice service network, that there are services associated with the service network, and for particular services, that traffic goes through VPC Lattice. If we need prod to dev communication, we still go through inspection. We still allow DNS to resolve to 10.something, right, that routes that traffic through Cloud WAN, through the inspection VPCs. And we achieve that level of security analysis of the packets, deep packet inspection, whatever is required when transitioning between these two types of levels of security. Now, we've built all these, right? We've added to our global network connectivity and segmentation that we've obtained with Cloud WAN, the integration with VPC Lattice, and that service control, service-to-service communication control with identity and network together, right? Now, let's see what the other side of the zero trust story is. Whenever we're talking about zero trust, we do split that into two different types of access patterns. It is service-to-service communication, and we've talked about it using VPC Lattice, and it is user-to-service communication, right? Users as in human users. And here's where the integration with AWS Verified Access comes into play, and where Chauvin is going to take us through the journey.
Thanks, Alex. So you saw how to build a global network, connect your branch offices, your VPCs using Cloud WAN. Then you build the application network, connected your services, microservices. So now finally, you have human users. You have employees and contractors and workers. They're working remotely from different places. And you want to connect them to these applications, right, which resides in Cloud WAN and Lattice. And we will connect them, but not through any other way, but through a zero trusty way, right? So we released a new product called AWS Verified Access at reInvent, and we went GA a couple of months back. What it does is that it provides secure connectivity to your corporate applications without using a VPN. So you no longer need a VPN. And if you think, it does three things for you. The first thing it does is that it uses zero trust principles. So it uses identity, device postures, and it allows you to write per application policies and does continuous validation. So you get better security posture, right? Because continuous validation, fine-grained policies, and zero trust principles. The second thing is that it's actually quite easy for administrators to use. And that will be the focus of next two slides. But eventually, let's say you have hundreds of applications. You can write a single set of policy at a single place using device, identity at one place, right? So easy to manage. And then finally, as we saw, right, so there is no VPN. It's actually better for end users. They can work from anywhere. They just need a laptop with a browser, and that's it. No clients, no agents, nothing, right? So let's dive deep. Let's see how it works. Essentially, verified access is a reverse proxy. Whenever your user type their application domain name on their web browser, so the request comes to this the reverse proxy, and it integrates with your existing identity system, your device posture management system. It takes all those signals, and it allows you to write policies. So you can say that, hey, this application is an IT application. All my employees need access to that. And this particular application is actually a core financial application. Only member of finance team with a compliance device, with disk encryption on, with malware protection on, they can only access this application. So you can write fine-grained per application level policies. And verified access will evaluate those policies against your data, like identity and device posture data. If they match, then only it allows the connection to go into your network. So let's see. You build this network, Cloud WAN, then Lattice network. And then at the end of the day, what happens is that your application, your corporate application, is represented by a load balancer, right? It's a load balancer, private load balancer. You don't want to expose it to the internet. What you do is that you spin up AVA, and AVA is your public endpoint. And AVA takes the request and evaluates and then only allows it. One other thing to notice here is that whenever you talk about security, so you want to build a very strong foundation using perimeter protection. You want to filter out all the broad threats, right, which come from the internet. For example, bots, cross-site scripting. So that's why we have integrated with WAF. And WAF gives you that first layer of protection, the perimeter protection. You can attach a web ACL and you can set up rules for all your endpoints. Let's say you have hundreds of apps. For all hundreds of apps, you have a web ACL. And then AWA gives you that fine-grained control, right? So then the second layer is that you have the fine-grained policies, which says which user under what security conditions can access the application. We already talked that you integrate with your identity providers and device management providers. And whenever the users they send the request, it evaluates the request based on your policies, and then allows the users to go in. But here is one more cool thing that I want to talk about, is that actually, you have already done quite a bit of networking, right, with Cloud WAN and Lattice. On the back end, to connect to your application, you don't need to do any networking for connecting AWA to your application. Whenever you add an application, what AWA does is that it drops something we call point-to-point interface or hyperplane ENIs from AWA to your application. Those ENIs are fully redundant. They take care of the availability, zone redundancy. And from your perspective, you just add applications and write policies. And AWA does the backend integration and networking for you. So that's it. Now you have your users connected to your applications and your network. And I will hand it over back to Alex.
Awesome. Nope, just this one. Thank you so much. Thank you. OK, so we've built all this together, right? We've built global segmented connectivity with Cloud WAN. We've integrated VPC Lattice for secure service-to-service communication. We've brought in AWS verified access for end-user access. So we have the complete picture and the complete deployment, right, that allows you to, again, bringing back the first statement, bring network and security capabilities together, right, to get you that layered approach into security, that defense in depth, starting with the perimeter of your network, right into the VPC with the security controls that you have at the VPC level, or between applications, between your AWS network and on-premises network in a hybrid world. So that being said, we would love to get your feedback. Thank you so much for attending today. Let us know. We'll be available after the session for questions. Let us know what you think, if you have any feedback, any use cases, any interesting key takeaways from the session that intrigued you. And thank you so much. Please don't forget to fill in the session survey. We love vibes. So thank you so much for your time today.